I've been scouring my local junkyard and I've collected a little bit of metal right here. Let me show you what I got. My local salvage center had some of these architectural steel beams, and I was told that it's pretty common that they get them in there. These are the offcuts for big projects. And I have these I-beams, which are basically 8 inches, and I think these are called C-channels, and these are right at 15 inches. So I had these C-channels are actually 2 feet long, and I was only able to afford 2 of them. They're sold by the pound at the salvage yards, and each one of those was about $100. And all of these I-beams, I got 2 more over there, plus I used 2 more for a little target range. They were another $100. Let's forget the 2 back there. That's for another YouTube channel. So all in, I have about $300 of steel that I could build a nice workbench. And what's cool is because I don't have that much invested in it, and I don't have space for another workbench inside my garage, I think this will be sturdy enough and thick enough steel that I can just leave it outside. Now my thinking is that I can use these I-beams for the structure and the legs of the bench, and these C-channels, if I can put them up to each other with maybe a 3/4 of a 1 inch gap in between them, that would make it a very nice tabletop, because I did look at them and they're exceptionally flat. So while this carport isn't level, it is somewhat flat, but I was worried that, you know, even a little stone or something like that underneath these long flat C-channels would get everything off. So what I did was I elevated it up off of these 2 beams, and then using a similar beams, which they should all be identical on top, I was able to attach a string going across left and right. And that way, by only being located on 2 points, I could shim the edges to make sure that these are level. That string, as long as it touched right in the center very gently, I assume that the bottoms of these channels are now in plane. So I just have to build the legs at the 90 degrees off the base. That's my thinking. Right now, I know these are a little over 10 feet long. I have a funny feeling that in the future, I'm going to want to bring these down to probably 8 feet. So I'm going to come in basically at 1.5 feet from each side, and that'll give me about a foot on the end to cut off in the future if I want, for both sides to end up with an 8-foot bench and still have a little bit of overhang there. Plus, it'll be close enough to the end, so it'll still be good and stable. And I have a feeling bringing them in a little bit will kind of make it less bendy overall. The legs won't be as far spread out. And there's no better way to get an accurate measurement than to just take it straight from the piece. Now supposedly you should have a bevel on the stuff you're joining, especially when it's thicker. But this is somewhat rounded over. So I think I'm just going to put a bevel right here, maybe a quarter of the way down, and call that done. Then the last thing is anywhere it's going to be hard to prep for paint, might as well do that now. Now while this dries and I still have the chop saw off, I'm going to go ahead and cut the legs, the 4 legs for this one. It's just going to be the same straight cut, so I don't need to film that one. And when we come back, I'm probably going to have to plasma out some braces. Now height-wise, I have read that metalworking tables, they range in height anywhere from about 30 inches to 34, depending on how tall people are. I really don't know what I'm going to like, so I'm actually going to go on the lower side. I'm going to cut the legs down to 29 inches, thinking the 2 metal pieces for the feet and the top are about a quarter of an inch each. And that way, worst case scenario, if I want it higher, I can put cinder blocks underneath it. Either way, I think it'll work out. Now, one thing about using these I-beams for feet is it's kind of a thin base, and as heavy as this thing's going to be, I can just imagine this just sinking into whatever it is. So I needed to put some kind of flat foot on it, and at the salvage yard, I couldn't find, the only thing I could really find were these, I don't know what they call them, angle beams, angle bars, or something like that. So I'm going to try and cut each side off so I could get a flat piece over there. I'm going to use my plasma cutter for that just because it's probably the best tool for that situation. But I've learned something about plasma cutters as I've gotten into this. Plasma just requires a lot more air than I actually thought. You know, I'd read the specs, but I didn't realize just how much it was. And while these are fairly inexpensive for what they are and do, it's the back-end accessory tools you're going to have. Because I have a nice little roll-around tank, Husky compressor that I've been using for, I want to say 7, 8 years now, and haven't really needed it anymore, but it just would not function with this. I hooked it up to my dad's industrial compressor, and it worked just fine. And really for me, I really do want to be able to go on the road with these kind of tools to do collabs and stuff like that, so I had to find some kind of solution. And if it required an industrial compressor, I just couldn't do any kind of metalworking with this tool. Now I did a lot of research, and I did find one that, according to the stats that the manufacturer says, just barely meets the minimum requirements that this particular plasma cutter requires. And I searched quite a while. If it works, this would be great because you could do in-the-field plasma cutting without having a giant compressor on the back of a truck or something like that. So this plasma cutter says it needs 90 PSI, and I forget the stats about how much volume it needs to, but I seem to remember the requirements were about the same. So I've got this plugged in. I'll turn this up to 90. I'm setting up my machine now, and I have a bit of a problem. You see, I'm a complete noob, and hey, if you see me doing something wrong, be sure and leave a comment down below in the comment section, because I'm sure somebody else, some other noob will benefit from it. But the rules I've read about is if you have two different thickness metals, which this piece right here, at its edge is a 1/2 inch, okay? And it gets thicker as it goes down. This piece right here is just a little over 3/8 of an inch, not even a 1/4 inch. So I need to set my welder up to do 1/2 inch, or actually the biggest it can go is 3/8 of an inch, in order to weld these two together, because the thicker metal is going to absorb more heat. And if it absorbs too much heat, the wire welding stuff doesn't get hot enough, so it doesn't actually blend into this metal, merging together. But then if I get too hot, this will burn through. But since they're touching, supposedly they're a single heat sink. So in this case, I'm just going to make it as hot as I can, which is for a 3/8 inch, and hope it works halfway decently. I mean, there's enough coverage right here, even if it's not great. I think for a bench it'll hold, but I'm thinking more this is a learning experience. So to set up this machine, I do have a chart on the inside of the door, but I've been using this automatic setup thing just because I don't know any better, and it gets me close. I am using the only wire I've got, which is 0.035. I think that's the largest this one will do. And I've got it set up for flux core, which it told me what the positives and negatives are going to be. And in flux core, basically it has that flux on the outside and the wires, the flux is on the inside, the wires on the outside. So the wire's pretty thin, so it actually has to send the electricity through the metal piece you're working and back through, because if it sends it through the wire all the way through this cable, it'll just burn up. So it's actually opposite of normal welding, which sends the power through the cable into the metal instead of from the metal to the cable. Then I need to set the thickness, and once again, this machine's only capable of doing 3/8. I'm just kind of hoping it'll work out that way. Maybe if I turn it up, wire feed speed and volts up to the middle, that's the standard settings for those. So I should be able to go up or down based upon preference. So now I'm just going to go around and tack opposite corners on the inside and outside, and then come back and figure out how to weld this sideways thing. That should be kind of fun. Okay, this next bit might be kind of hard for me because I've never welded, I guess, vertically sideways. And the problem is that whenever you're welding, you're actually creating molten metal, and metal wants to follow molten stuff, liquid stuff wants to follow gravity, so it's going to want to fall down, which is why when you're welding up vertically, you start at the bottom so it kind of cools and follows up. If you were to follow it down, you would be following the molten droplet all the way down. It just doesn't work out. The second thing is, well, this piece right here, it was rounded over, so I didn't need to put a bevel on it. And the idea with having a bevel there is whenever you weld it, it kind of gives it a small ledge to sit on instead of just running off immediately. And within a fraction of a second, it starts to solidify, so that's okay. But if it's dripping during the half second, that's your problem. So it's going to sit on that ledge, and then you bevel the top section up there so you can shove the puddle up in there. The downside is I have to have it so hot because this is thick that I don't want to melt this material. So what I've been reading is you focus all the heat into this one and just every now and then come up and touch the top one, so it just slightly melts the top one and melts the bottom one more. But this being a big heat sink. And then you have to get the motion steady, and because this has a flux instead of a gas, normally gas goes around this through the hose to prevent the molten metal from reacting with the air. Well, flux core has another substance that melts and sits on top of that molten metal to prevent it from interacting with the air. So I have to drag it, because if I were to push it, that secondary molten stuff that sits on top would get encased in it. So you kind of drag it down. They say if it's got slag, you drag. So that's what we're doing now. So in the course of 30 seconds, I got to get all those parameters right. Otherwise, this won't be a very good joint. So wish me luck. Okay, this isn't going good. Okay, that didn't go too good. It actually at one point in time dripped down onto the ground. Oh, that's ugly. Tell me if I'm wrong, but when you got holes like that, that tells you you're not going fast enough so that the flux is getting inside it and then popping. And then I was going too fast there, not fast enough, and only about right there did it start working halfway decently. Maybe I'll get better as I go around. I'm sure I can always grind it smooth. So here's the results. This one right here, I did 2 passes on to get it right. This one over here, I did 1 pass and then I went through the center section a little bit more. And then finally, this one right here was 1 straight pass. The difference here was I took the gun and instead of aiming it into this piece right here with that recess right there, so I kind of aimed it up and at a back angle like that. And it just worked a lot better. But those were the hard ones and the least critical ones in my opinion. I'm not going to do the center section right here until I flip it over. That way I can weld those inside corners going down to let gravity help me. Next up, I've got to add the feet to the legs. I need to do that now. And these are those pieces I cut off of the angle iron. And the idea is I'm just going to lay them right like that and just weld them on, which I'll turn them down, turn them over, tack them on this side, and then weld them all the way around. And then I can weld the bottoms to the underside of the tabletop. Yeah, fillets where you can let the gravity do its work are a lot easier. Probably a little bit too much on this one, not enough on this one, but they're getting better. Yesterday we made some good progress. Today I'm just going to take some time and hit everything with the wire wheel before I put the legs on, just because I have access to most of the spaces. And that's just in prep for when it's all said and done. I can throw some rust-prevented primer and paint on it. It is going to be outside, but might as well protect it a little bit. So after a light dressing, I put a wood board right down here, and I'll use that consistently all the way around to get spacing right. And on this particular leg, I got the cut pretty good on the base. So it's 90 degrees here, and I have it set right here, and it's pretty much right on right there. Maybe a half a degree off. I'm just going to say that's good enough. So I'm going to tack the bottom and weld it up. Word to the wise, don't run out of welding supplies on the weekend. 4 hours. A little bit. So I've got 2 sides of the legs fully welded on, and now I'm just going to position these sides so I can get the measurement from here to there perfectly. Because I like to create not only a little brace between these two, because these being longer than they are wider, I think this direction they'll be very stable, but this direction it's a little bit thinner even though it's welded at multiple spots. Just to be sure, I'm going to add a brace here, and that'll also be a great perch for a shelf later on down the road. And to make that brace, I just plasma one of the I-beams in half, and I'll just cut it to size. And I think, you know, welding a T as a brace, that'll make it pretty strong. So if we're getting that color change from the metal coming through, doesn't that mean we're getting good penetration? Well, there you go. Pretty much done. Just a little cosmetic stuff. I'm just going over the last of it with a flap disc to get some of this paint that I'd painted on it. But got shelving underneath, got a little flash of red. I did test it out with a very long straight edge, and these are completely flat this way, and this one is completely flat this way. One issue is right across this beam right here. There's like maybe a 1/16 of an inch wiggle this way, that way, but for an outdoor bench, it's perfectly fine. And I talked to somebody, and he said that some way with an acetylene torch, I could probably heat up that middle beam right there, and it would kind of come down a tad bit. But really, for what I want to do, this is perfectly fine. $300 from Junkyard Scavenging, and once again, the place I went and a couple other places said it's kind of common to find these things. Maybe not 10 feet long, but 8 feet, 6 feet, that kind of stuff. And I-beams are everywhere. Well, I hope you enjoyed this video. Well, y'all be safe, have fun, and remember, it's always worth the effort to learn, create stuff, and share it with others. Be safe, have fun.